Absolute value functions lesson 3.4. We're going to add another function here to our parent list. So if you recall, kind of back in the day in chapter 1, we kind of went through some parent functions. So let me just quickly kind of review those. So linear is where the parent function is right here, comes right through the origin, and the equation was y equals x, or if you want to think f of x equals x. Either way, quadratic, that one looked like this. It was a parabola, comes right down, again through the origin, and that one is y equals x squared, or a power of 2. Linear, remember, is the power of 1. Cubic, well, this one, they all kind of have the same shape to where you come up, you cut through 0, and you finish up. So that would be y equals x to the third. And then we included the old square root function, which started at 0, 0, and looks something like that. Y equals radical x. And then we transformed them. We moved them up, we moved them down, left, right, and then we also stretched them or compressed them. So we're going to kind of do similar things, but today we're just going to focus on absolute value. So let's kind of go in a little bit deeper. So absolute value, first of all, just remember, like, if I was going to make a table, because I might not know what this function is going to look like if I graph it, but if I were to make a table, and I'm like, okay, x and y, and let's start putting some numbers in there. Well, the absolute value of 0 is 0. So I have that spot on the graph. Maybe I'll do these in blue so it shows up a little better. And the absolute value of 1 is 1. And the absolute value of 2 is 2. And I think you can kind of see where this is going. We're basically going to create this line with a slope of 1, 45-degree angle, forever in that direction. Now, if we look at the negatives, though, if we put negative 1 in there, the absolute value of negative 1 is positive 1. And the absolute value of negative 2 is positive 2. So what ends up happening is you get this V-shaped pattern emerges. So there is the parent function, y equals the absolute value of x. It's a V that's centered at 0, 0, and it opens up. All right, so that's kind of important. Now, we're going to do some things to this. We are actually going to, there's lots of things that could happen, but we are going to mess with moving it up or down, which is going to be this back number. Outside is going to move it up, negative is going to move it down. Then we could also do plus or minus, and they usually use the thing h in there. That's going to be a horizontal move left and right. And then we could have a number in the front, which they typically call a, and this number could stretch it vertically if it's greater than 1, so like if I put a 2 there, or it could compress it or smash it down if that number is less than 1. And then we could also reflect it if we put a negative in front of there. So we'll get to all that, but I just kind of want to show the different ways we can manipulate this function. So let's scroll down, write a new equation. So if we want this thing to move 2 units up, so basically we have the parent function up above. 2 units up is just going to shift everything 2 units up. And what that means is you're going to take your normal parent function, and 2 units up means you're going to add 2 to the back of it. And if you plugged all those values in a table, it would all check out. And we don't really have to do that. But if you wanted to make an XY table and put 0 in, instead of getting 0, you're going to get 2. Put 1 in, you're going to get 3. And it's going to move it up. Now, if we wanted to go down, that would have been a minus at the back side. Now, the right and left are a little bit tricky. So you might think that because the x-axis going to the right is positive, that we would want to plus that, but it's actually different from what you would expect. So 3 units to the right, this one is going to be y equals the absolute value. And if you want to do a horizontal move, actually let me do this in black, kind of highlight it better. If you want to do a horizontal move, you make a move inside the absolute value bars, and 3 units to the right, we're actually going to take away 3. And even though it's take away, it's opposite when you're going left and right. And this is going to shift our graph 3 to the right, and now our V is going to be pretty much right there. And we will get this kind of picture. So it's the V, it's just moved over 3 to the right. But the key thing to remember is if it's right, it's going to be negative. All right? Now, if we want to reflect this thing over the x-axis, so if I want to reflect it over the x-axis, that means that I want to use the x-axis like a mirror, and we're going to fold it and flip it right down here. So it's going to completely go the other direction. And then whenever we want to flip it like that, all we have to do is make one adjustment, and that adjustment is just put a negative sign in front. If you put a negative sign in front, it's going to completely flip that thing all the way over to where it points down. We really can't reflect it across the y-axis, because if you start with a V and you reflect it, it's just going to end up being the same exact thing. So I won't be asking that question on this one. All right, now what if we want to do kind of a combo, I'll call it? What if we want to do a couple different things? So we want to go 2 down and 3 left. Well, let's do those adjustments, and maybe again I'll color code this. So we always start off with y equals absolute value of x, and then we're going to do some things. Well, we're not reflecting it, so there'll be nothing in front. But if I want to do 2 units down, that happens at the back, so minus 2. And if I want to do 3 units to the left, well, that's going to be inside the parentheses, horizontal, but it's going to be a plus 3. So remember, left is going to be positive 3. All right? And if I wanted to actually draw that thing, 2 units, so the vertex is going to move. It was here at 0, 0. It's going to go 2 down and 3 left. So now we have a vertex right here. And it's going to go up that way. It's going to go up that way. And there we go. That's going to be the graph of it. So I'm transforming it, and I'm writing equations without really having to make tables, as long as I understand the mechanics of how this works. Number 5, translate f of x equals absolute value of x so that the vertex is at negative 5, 3. All right, so they're just wording it a little bit different. So I want the vertex, which the vertex is kind of that little, well, the vertex is right here. It's that V point. I want that to be at negative 5, 3. So I want to go left 5, up 3. All right. So when you kind of translate this, that's left 5, and then that's up 3. And again, we know what the graph's going to look like. That's the easy part. Just kind of draw your V. But let's put the equation together. So I kind of have my parent function. And let's see what we got to do. Well, we got to go left 5. So that's going to be a positive 5 inside. And then up 3 means we're going to slap a plus 3 at the back side. And we're good to go. All right. Now we got to deal with the stretch and the compress. Which isn't going to be too bad. So the big difference here is there is a number in front of, like directly in front of, the absolute value bar that's going to vertically, it's going to increase it, it's going to make it taller. And I don't know, I'd like to maybe do a little table for this one. So let's just put a few values in. We'll put in 0, and then we'll put in 1, we'll put in 2, and we'll go -1, -2, and hopefully that'll be enough. Usually 5 points is pretty good. So let's put 0 in. If I put 0 in there, well, the absolute value of 0 is 0. 3 times 0 is 0. So I get an answer of -6. So 0, -6 is on the grid. And I would expect that. I would expect that because negative 6 at the backside means you move down 6. So I'm like, all right, that's exactly what I thought was going to happen. Well, now let's put a 1 in there. If I put a 1 in there, the absolute value of 1 is 1. So 3 times 1 is 3, take away 6. Well, that's a negative 3. So when I put 1 in there, I get negative 3. So over 1, down 3. And if we put a 2 in there, absolute value of 2 is 2. And 3 times 2 is 6. And 6 take away 6 is 0. So I have the point 2 comma 0 in there. And maybe we'll do one more. I don't know. Let's pick another point out here. Let's go to, I don't know, maybe 5. 3 times 5 is 15. 15 take away 6 is 9. So I got to do 5 comma 9, 3, 4, 5, way up here. So it looks like it has this slope of up 3 over 1, up 3 over 1, 3 over 1, 3 over 1. So it's a really, really steep, tight V. And just because all absolute values kind of do this, I kind of know what the other side is going to be symmetrical. But we could put it in, you know, if I plug in this negative 1, well, the absolute value of negative 1 is 1. And then 3 times 1, take away 6. Well, that's negative 3. So negative 1, negative 3. And you're going to find out that it does the same slope shooting up. So it's very similar to the parent function, except for there are a couple changes. So remember, the parent function was right here. That's the old G. And basically we moved down 6. So this part, that was moving down 6. And then this part kind of stretched it vertically. Kind of made it scrawnier, pulled it. All right, so the next one, compress a transformation. Let's kind of look at this. And a compress happens when the number in front is less than 1. All right, so if I'm less than 1 in front there, it's going to compress it. I also see that we're going to move to the right 3 units. So let's maybe see if we could kind of cheat this one. You know, we saw in the last example, you know, normally when your y equals absolute value of x, that means that you go over 1, up 1. That's kind of your pitch or your slope. Well, with this problem over here, we went over 1, up 3. So we were quite a bit steeper. That was our slope of 3. Well, for this one, I think our slope is going to be a half, which is going to be up 1 over 2. So it's going to be flatter. So let's just check it out. If we move 3 to the right, and then we go up 1 over 2, up 1 over 2, up 1 over 2, and back it on up, 1 and 2, 1 and 2, 1 and 2, 1 and 2. Keep right on going. Looks like I have a pretty flat little V here. And we could go back and we could try to verify that maybe with our table. So let's see if these points get verified. And let's check out the vertex first. So what happens when I put 3 in for x? Well, 3 take away 3 is 0. Absolute value is 0, 0. 0 times a half. That checks out. Let's pick another point. Let's pick this point way over here. So we want to verify that negative 5 comma 4 works. Let's see if negative 5 comma 4 works. So I'm going to punch this in. It'd be 1/2 times a negative 5, take away 3. We're hoping that it equals 4. If it is, then we got a good picture. Well, that's 1/2 times the absolute value of negative 8, which is 1/2 times positive 8, which is 4. Sweet. So our prediction was right. So we knew there was a horizontal change to the right. We knew that the slope was changed. So our intuition kind of led us in the right direction. Hopefully this helps you out for transforming our parent function y equals absolute value of x. And I don't believe there are any more examples. we get right into the practice. So good luck. See you.